Hey everyone, thank you for joining the Isaac Sim office hours. Wishing you all a happy new year. In today's office hours, we'll be looking at the ROS workflows which are part of Isaac Sim, and we'll also be taking a look at the newer features which have been gone out with the newer release, which include building your custom messages with Python and having custom OmniGraph C++ level nodes as well, and running it with Docker, some exciting navigation samples as well. And before we jump right into all of this, we also have another guest joining us today, Ayush. Ayush, would you like to go ahead and introduce yourself?
Yes, hi everyone. My name is Ayush. I work on the Isaac Sim team and mainly with developing the ROS bridge.
Yep. Glad to have you here, Ayush. I think we'll be walking through the navigation samples as well later, and Ayush has worked closely on them, so he'll have some tips and pointers for us. So I think we're going to get started. The main things which I wanted to cover here were a quick overview of importing the robots into Isaac Sim. So we'll be looking at the URDF importer, setting up sample sensors, and making sure our ROS OmniGraph nodes are also set up correctly so that our robot can publish and receive data from ROS. And we look at custom messages, Docker workflows, and navigation. So hopefully that sounds exciting. If there's anything else related to ROS which you've got questions about or you're looking for more insights at, please let us know in the chats. We'll try our best to answer there. And I'll start sharing my screen so we can jump right into it. Okay, so let me open up the documentation. I think that should be your best starting point right here. So the first thing which you would need to keep in mind if you're using the ROS to bridge with Isaac Sim is that we are supporting both Foxy and Humble right now. So Foxy is supported on 20 Ubuntu 20.04 and Humble is on 22.04. And the reason in this table Humble is recommended as the highlighted one right here because the workflow for using ROS with Humble is easier because Isaac Sim is based off Python 3.10. And what that means is that when you build your Python packages with ROS, the default value of Python, which is used by your system level, is Python 3.10 in case of Ubuntu 22. So all those packages can then directly be used with Isaac Sim. So you don't need to worry about making sure that they're built with the right dependencies. But in case of Ubuntu 20.04, which is Foxy, the default Python value there is Python 3.7, and that is something which we also do highlight down here. So the default Python version is Python 3.7. So you'll be able to load the ROS to bridge with IsaacSim in that case. And what will happen is that the OmniGraph nodes associated with the ROS to bridge, like publishing laser scan, camera information, or even subscribing to topics and stuff, that will work as expected. But at the RCL Pi level, that is the Python interface for ROS, because those packages would be generated with Python 3.7, whereas IsaacSim and Omniverse would be running with Python 3.10. You'll have trouble to try to use RCLPy directly. So to go around that, we do provide internal libraries and versions of RCLPy as well, and that is something which we'll be looking at uh, right now. So this is the terminal right here from where I'm going to launch IsaacSim. So there are two ways to go about it. If I do have ROS installed on my system, then I can source my ROS installation and start up IsaacSim. And for the first example, that's what I'm going to do right now. So I'll go ahead and source my Humble installation. And okay, so yeah, ROS, the sourcing is worked fine. I'm able to source it and list out the topics which are publishing and subscribing to nothing right now. Let me go ahead and start up Isaac Sim. So another thing which has also happened now is the ROS2 bridge is enabled by default. So previously on Isaac Sim, the ROS1 bridge was the default version that has been changed to the ROS2 bridge. So what will happen right now is as soon as you do start up Sim, by default, the bridge which is enabled should be the ROS2 bridge. So we can quickly go ahead and check that too. So if I go into extensions right here, can see that the ROS2 bridge is enabled. So let me just make sure that, sorry, the ROS2 bridge is enabled. Yeah, let me just make sure that I'm able to disable it and enable it again. I'll pop up the terminal right here. And okay. So yeah, I do get the log right here saying that it attempted to load the system level RCLPy, and this refers to your sourced humble installation level RCLPy, which the bridge has tried to load. And it was able to load it successfully, so you do get the message that RCLPy loaded, and the bridge also has started up. So it looks all good in terms of sourcing your ROS installation and then starting up ISACSIM. The other option would be that uh, for example, if I do not source my workstation, my Humble installation. So let me start up another terminal right here. Let me go over to i6sim, and I'm not sourced my ROS2 installation. So now I'm going to start up i6sim as is. So even in this case, because the default bridge which is to be enabled with ISACSIM is the ROS2 bridge, that is what ISACSIM will attempt to load. But because it will not be able to find any pre-existing ROS version on your system because you've not sourced your workspace, it will try to load the inbuilt system libraries which come as a part of ISACSIM. Let's see if it actually did get enabled though. So here we can see that the bridge did not get enabled. Like you can see that it is disabled right here, and let me see if I can find the log corresponding to that right here. Okay, so yeah, you will see a few logs being printed out over here, and see here's the part where it does attempt to start up the bridge. Then it complains that there is no sourced ROS version available in your environment variables. It tries to use the internal libraries which come as a part of i6sim, and it is not able to use that because the corresponding environment variables have not been set. So the way to actually solve this problem is given right here. To use the internal libraries included with the extension, please set these following environment variables. So what I'm going to do is I'm going to stop sim, I'm going to set those environment variables, and then I'm going to start sim again. And what will happen in this case is that when ISACSIM will start up and attempt to load the ROS2 bridge, it will now use the libraries which are a part of the ISACSIM installation. So they come with pre-packaged with ISACSIM, and as soon as you set these environment variables to the corresponding values, it will be loaded dynamically from there. So let me go ahead and stop uh, sim from here, and I'm just going to set. So the first is the RMW implementation variable, which I need to set. I've set that. And the next one is the LD library path, which is responsible for dynamically loading the libraries at runtime related to the ROS side of things. So I'm going to do that. And I've exported both the variables. Now let me try starting up ISACSIM. So remember, I've not sourced any ROS installation here because I don't have it with me. And this is also particularly useful if you are using Isaac Sim in Docker container-based workflows. So for example, if I have a Docker container in which I'm running Isaac Sim in, and I have another container which could be having all my ROS-related software stack running on it. So the Isaac Sim ROS2 bridge does not need to have ROS installed at the same location to actually enable it. So it comes pre-packaged with its own set of libraries needed for enabling the ROS2 bridge, and you can leverage that directly. So let me go ahead and open up the extensions and look for ROS. So this time the ROS2 bridge did get loaded. So the solution to our problem was just making sure that the environment variables are set up correctly. So here you can see the log being printed out correspondingly using backup internal Humble ROS2 distro libraries, and it will also load the corresponding RCL file for that. So This is something which you can do if you are particularly using Docker-based workflows, or for example, if you have ROS running maybe on another system, or you're doing software in the loop or hardware in the loop, in which case you don't want ROS on the same system where ISACSIM exists. You can keep them isolated in terms of the environments they're being running. So this is what it looks like when you do not have ROS installed on your system, and that is one way to go about it. Let me close this and we can get back. It'll be easier to follow through once you have ROS installed on your system. So the next thing which we will be looking at over here is a basic use case of the URDF importer. We'll import a simple robot into the scene, and we'll see how you can add basic ROS related OmniGraph nodes for subscribing to, for example, twist messages so that you can control your robot in simulation. So for doing something like that, the first thing would be that Isaac utils workflow, and we look at the URDF importer. So the URDF importer is an extension which has also been open sourced with the previous release of Isaac Sim. Let me go ahead and find the GitHub location for that. Isaac Sim. So this is the importer right here. So it's the same version which comes compiled with Isaac Sim, and you can follow through on the instructions on the README right here to understand how it works and how you can use it for your own robots. We'll be taking a quick look at the TurtleBot sample, which is also a part of the ROS tutorials within the Isaac Sim documentation, in terms of how to get it into simulation and look at the basic physics once we do get it in. So these are the import options which you do get with the URDF importer. We do not want the base link to be fixed because the TurtleBot is going to be a mobile robot, so it needs to move. So no base link. This is probably going to be more useful for manipulators when you are importing them into the scene. And we're going to change the joint drive type to velocity. I think those are the only two changes which we need to make. Let me go ahead and specify the input file. Uh, TurtleBot. And we do have TurtleBot 3 description, the URDF. I'll go ahead and import the burger. It's just going to overwrite the one which is already there, and that's fine. So right here, you can see that the TurtleBot has been imported into the scene. Let me actually create a smaller environment around it. Right now, there's nothing. It's basically just in the air. Create a small grid room and get the camera. I can go ahead and close this right now. So this is what our TurtleBot looks like right now. So you can go ahead and on the stage take an exploded view look at what the joints and what the other meshes do look like. So the base link right here will contain the main joints which are associated with our wheels, and you can see that we've got two revolute joints set up to the places corresponding to the left and the right wheel of that TurtleBot. And just to make sure things actually look like, let's go ahead and set a target velocity for these wheels and see the TurtleBot move as expected. I'm going to do this. Let me zoom out right here and hit play. So you can see as soon as I hit play, the TurtleBot did fall onto the floor, and yes, it does seem to be moving uh, right ahead. So what happens with the URDF importer is the physics related to the robot, which is described in that format, does get passed through and represented into the USD form so that it can actually work correctly as expected. The only thing which you do need to add on top of this is, for example, if you have other sensors on your robots like lidars, cameras, or IMUs, those will need to be added manually. And for doing something like that, what you could do is you can go here, create. If it's a simple camera, you can do that. In later examples, we'll be looking at the newer sensors which are a part of the latest ISAC-SIM release, for example, the real sense camera, and how you can mount that on top of a TurtleBot and hook it up to ROS so that you can send over the RGB data to and visualize it in RVIS, for example. So these are the sensors which are a part right now of the Isaac Sim collection. We've got the physics lidars and the latest RTX lidars as well, and support for more different configurations for these corresponding sensors. So you can go ahead and actually also look more closely at what the other aspects of the Turtlebot burger do look like, but it's basically just making sure that your meshes are arranged correctly in terms of the hierarchy and the joints are set up correctly so that you would not need to worry about rigging physics to your robot once you get it into Isaac Sim because uh, if you do not have a URDF representation, you can also make a use of 3D CAD model importers, which are a part of Isaac Sim extensions. Let me go ahead and find the link for it. It should have been okay. Uh, I'll make sure I look for that link and paste it on the chat right here. But yeah, you should be able to bring your own 3D CAD model into Isaac Sim. And the only thing you would need to do if you are actually following that workflow is set up the physics yourself, which can be a little cumbersome depending on how complex of a robot it is with the number of joints and various parameters which you would need to set. So if you do have the URDF representation, that would be an easier way to move ahead. So let me quickly go back to our live stream page in the meanwhile and see if we have any questions which have shown up. Sorry about that. Ayush, do we have any questions which we would want to answer right here?
Yeah, we have a couple questions. The first one is from Christopher. I see that you have posted a script or a file path to a script. Could you just maybe elaborate on what your question is regarding this script? Also, the second question that we have is from Mohammed, and he's asking if we have something like the URDF importer, whether it'll work for quadruped.
Yep, you should be able to use any robot representation, right? Ayush, I think if you have the URDF in, you should be, and I think we also have samples for quadrupeds this time. Let me look at the robots right here.
Yeah.
We do have two quadruped samples which are a part of Isaac Sim. Let me go ahead and actually open them right here. Otherwise,
Yeah, so exactly. So if you have like a URDF already defined with any sort of robot, it should be able to import into Isaac Sim. And obviously, if you face any issues, please don't hesitate to reach out on the forums, and we'll make sure to get back to you.
yep. So this is one sample of a quadruped right here. So at least the one which is on the screen right now is the USD representation. But there should not be any issue in terms of using the URDF importer like we just did and importing a quadruped or a humanoid or any different robot with Isaac Sim. And like Ayush said, if you do run into issues, please reach out to us on the forums. And for setting joint attributes right here, I think there was a question over there as well. How can we control a robot's joint, such as a humanoid robot? I think the procedure for controlling the joint parameters for any robot in that case is if you're using Python scripts directly, you can use the related APIs for the controllers at the joint level. Or if you, for example, are using just the initial GUI mode to sort of figure out how the robot works, so like we did for the Turtlebot, where we set the wheel velocities by setting the target velocities for the joints. That is something you can do for other robots as well. So for this animal robot, you should be able to find all. So there are a lot of joints in the quadruped, for example, right here. So let me bring this right here. So there are a lot of fixed joints related to the base. You will also have revolute joints around the hip hinges. So all of those joints are defined as a part of the USD and they can be set to target positions or velocities depending on what sort of joints they are. And they can also be controlled via Python scripts if you're, for example, opening the scene, adding the robot into the scene and making it uh, perform a certain task, that can be done.
Yep. There's another question from Adlan asking basically he had a problem with documentation using importing URDF using Python. Yeah, it seems like you have an error that pops up in the terminal. Could you maybe share with us what the error was?
Yep, and you can also post it on the forums, and if it's already posted on the forum, you can link it right here, and we'll make sure that we check back internally as well if we can help out. So I think, yeah, do you think we can proceed ahead, Ayush?
Yep, there's just one more question I wanted to address from Hattie that asked about adding documentation for creating custom nodes for ROS2 publishing subscribing. So actually, maybe Risha, if you can pull up the tutorials. So we do have
Yep.
tutorials for creating a custom, C++ node as well as Python nodes. And there's another one that we are going to create eventually, which is how you can create your own custom Python Omnigraph node. And I
Yep.
can Yeah, exactly. So there you can, define your custom messages there. And this is how you can link custom messages with Isaac Sim and make it work. And obviously, if you want to create your own node, you can either, there's either two ways. So one is you create your own extension and, create your own just create your own extension, which has your, all the code that you need to run your publishers and subscribers. Or something that will come up eventually is how you can create a custom ROS publisher or subscriber inside an Omnigraph node using specifically the script node. So I can actually link to the forums here a solution that we have currently, which I think you can use for now until we have a tutorial that we'll put in soon. So thanks for that
Sounds
question,
good.
Hadi.
Yeah, Hadi, and also we'll be looking at Python custom messages and C++ related OmniGraph custom nodes later today. But right now, with the newer design of the ROS2 bridge, where you can now source your workspace, so if you have a custom message built with Python 3.10, which is the standard for Ubuntu 22 and Humble, you can just source that workspace and you should be able to import that message directly with IsaacSim. So that's how you can access it in a straightforward way. And for the C++ side of things, it is a little bit of a longer process, and we'll be walking through that as well. So let's quickly get back to what we were looking at here. So uh, we don't actually need the animal right here, but I guess it's okay. So the next thing which we would want to do is understand how does how do various components under the ROS2 bridge work with IsaacSim. So let me open up, let's create a simple action graph right here. So now action graph is basically just a framework which is going to allow you to leverage various OmniGraph related ROS2 nodes which are written as a part of IsaacSim to do simple tasks. So for example, if you want to subscribe to a twist message, or if you want to publish over uh, the RGB information from a certain camera in simulation, we have corresponding nodes written for doing things like this with the ROS2 bridge, and you can just connect them up. And uh, once you do that, then you'll be able to access them from the ROS side of things. So let's quickly look at what ROS2 nodes we do have as a part of the IsaacSim bridge. So there's a camera helper node which we'll be taking a look at on publishing the camera related information from the RGB side of things, and even depth, point cloud, and all that good stuff over. And also have a couple of other important nodes related to navigation in particular is the laser scan message, the LiDAR information can be published over, then odometry, the transform trees, and the point cloud. So we've got OmniGraph nodes for doing all of these tasks, and a quick way to look at how they work is I'm going to spin up one right here. So let me go ahead and a subscribe twist message and a playback tick node. So there's a very simple OmniGraph right here. On playback tick is basically when I hit play and there's a simulation step which happens, and as soon as that is done, it is going to trigger this subscription for ROS to node. And once this is triggered, these are various parameters from the subscription node you can set up. So there is no context. This is a default context. You don't need to worry about it for now. No node namespace. And we'll be subscribing to a topic called CMD well. So this is just basically the command velocity which you can publish over from the ROS side. And the inputs to the nodes are the topic name, the queue size, the node namespace, and the context. And the output is the angular and linear velocity which is obtained from that corresponding topic. So let me go ahead and hit play right here. I think that quadruped is going to fall down here. That was expected. And let me go ahead and open up a new terminal too. And here I'll source my humble installation. And we don't need this for now. And I can take this down here. So I can see that my topic list is showing up with CMD well topic, and if I do an info on that, uh, I can see that there's a subscriber which was spun up from Isaac Sim right here. So let me go ahead and run a simple teleop twist. So this is the teleop twist interface right here, and I'm going to set the speeds for the linear velocity and the angular velocity from here. So if I do hit I on my keyboard, I would expect that the linear velocity is going to be set to 0.6. And you can see that the output from our OmniGraph node, which was in sim, is now correspondingly changed. And if I'm just going to turn it around on the z-axis, so let me go ahead and do that, and I can see that that corresponding output is also being set to the OmniGraph node value here. So that shows you that our subscriber seems to be working, that whatever values we're passing in from our system level ROS side are going through onto the OmniGraph node and being set over there. So let's look at a better use case. Obviously, this is not very helpful where I can just see the output showing up. In an ideal world, I would want to be able to drive the turtle bot with these OmniGraph nodes. So let's go ahead and take a look at that. So I already have a stage prepared for us to take a look at what it would be like. We don't need to save this stage. So it's basically the same turtlebot which we had right here, except I've added a little bit more onto the action graph which we had. And it looks a little complicated, but don't worry, it is straightforward. So I'm going to walk through the action graph as well to understand what's happening here. So on playback tick and on the ROS to subscribe twist are exactly the same. It's the same topic it is subscribing to, and there's nothing which is changed right here. So now once we do get the velocities from the subscribe twist message, the next step would be that we want to pass it into the differential controller, which actually then moves the robot. So it's basically just those two steps. The velocity needs to be scaled to the Isaacson stage units, and that is done for the linear velocity. And once the linear and angular velocities are obtained, they're passed into the differential controller, which then obtains the velocity command for the body and passes it further to the articulation controller, which moves the turtle bot. And that velocity command is obtained from right here, the connection which is present between these two nodes. And we are going to be driving the two joints, which are the left wheel joint and the right wheel joint right here, which were a part of our turtlebot initially. So these two joints are going to be driven from the command velocity, which is going to be coming in from the subscription to uh, the CMD well topic, and it's going to be passed to the articulation controller. So let's take a look at how it would work in that case. I'm going to hit play. It's the same as expected. And let me go ahead and run the telegraph twist again. I'm going to slow the velocities down a little bit because that is too fast for the robot. And I'm also going to slow down the turn a little bit. So this is how you can see that I'm able to drive the turtle bot around, and it's basically the same teleop twist commands which I was using initially, but the difference being that I can now set the controller parameters from the subscription and then correspondingly control the robot in a way I would want it to behave. So this is a simple way to do make sure that your subscription passes in the correct values to your controller so that you can actually control the articulated body. And the other interesting thing which we would also be looking at right now is, so we also have added a camera on top of the turtle bot right here. If anyone noticed earlier, this is something which I, so this is the real sense camera which we have and is a part of uh, the latest 2023 release of Isaac Sim. So it's this camera right here which I've made sure is put on onto the turtle bot and moves with it. So what we can do is we can go into the perspective of that camera and actually look at how the viewport is. So this is the robot's view of the world right now, which we're looking at, and it's from the Intel RealSense camera. And the next thing which we will now be doing is we're going to be publishing this information over to ROS as well, so in the form of an image message. So let's create the action graph for doing that right now. So what we can do is we can go ahead and we're going to create another action graph. We'll create a new one. We don't need to use the same one as is. And I'm going to use the camera helper node right here. Camera helper node. I also need the render product associated with uh, the real sense for that particular camera. So I'm going to need that, and I'm going to need. So these are the three nodes I'll be using on playback tick, on create render product, and ROS to camera helper. So the tick nodes can directly be connected from the exec side of things. For a camera prim right here, what we're going to do is let me add a target, and let me go into the turtle bot. So this is the real sense which is mounted on the turtle bot right now, and I'm going to look at the uh, left camera prim of that Intel RealSense stereo camera. So oops, that, sorry for that. That was okay. So I've set the camera prim to that. I've also set the render properties. So it's going to be streaming at 1280 by 720. So it's an HD image which is going to be sent over to ROS, and the render product path associated needs to be passed over to the camera helper. So make sure that the connection for this and this is also done. So let's take a quick look at what the ROS to camera helper node looks like. So we are using the default context again here, and you can use a different context. For example, if you are using a network which might be clogged and there are multiple people using ROS on the same network, so the best practice is setting a domain ID corresponding to each workstation or isolated set of ROS functionality which you would be looking to run. And once you're using a ROS domain ID, then you can leverage the ROS to context node, which sets the domain ID for the corresponding action graph as well. So It's not going to be useful right now, but that is something which you might want to look at depending on how many people are using ROS on the same network at a particular time.
And
So the
just to
frame,
jump in there, the best way to set the context in this case is use the ROS2 context node. And so in there, there's kind of two things. So by default, the environment variables are enabled. So it will use whatever ROS domain ID you have set in your terminal when you first launch Isaac Sim. But then if you uncheck that, you can actually put in the domain ID number that you would like.
yep. So for example, like I just said, I want to set the domain ID as 12. I set it to 12, and
And make sure to
then I would,
uncheck the use domain ID environment variable. There you go. And so now it'll use 12 for sure.
and you would need to connect it out to that context. I'm not going to do that right here because I've not set any context for the other stuff happening on my. I've not set any domain ID for the regular ROS installation for right now. So, but that is something which you can take a look at depending on how your use case turns out to be. So, coming back to the camera helper, the SIM camera is the camera ID which we'll be using, the frame ID, and we're going to be publishing on the RGB topic with the type of topic being published on is RGB. So we're going to be publishing in image information. The other options which also do exist are you can publish depth information, point clouds, instance and semantic segmentation masks, and you can publish bounding boxes as well. So depending on what you're looking at, that could be interesting. So the other thing which we also should add is we are going to be publishing the image data over. So we should also be publishing the camera information for that corresponding node. So let me do that right here as well. So let me set up another camera helper node, and it's going to be connected to the same render product path which was used initially as well, because it's going to be for the same camera. Exec in is also going to be from the render product node. The only difference being here, I'm going to say the topic name is going to be camera info, and the type of information which is going to be published is also going to be camera info. So what this action graph is going to do now is when I'm going to hit play, corresponding to the render product, corresponding to the camera which we have selected, which is the Intel RealSense camera right here in the scene, it's going to create the render product and it's going to pass it into the two camera helpers right here, and out of which the top one is going to publish over the RGB information, which is the image itself, and that is something which we'll visualize in RViz. And the bottom one is going to just publish over the camera info message. So let's go ahead and do that right now. So, okay, simulation is playing. I've not deleted my subscription nodes which are actually responsible for teleoping. So the teleop is also working. Don't worry, we've not lost that. We can take a look at the topics which are present right now. So now we can see that there are two additional topics. CMD well was something which was there initially as well, but we can see the camera info and the RGB topics have also shown up. So let me go ahead and run RViz right now. So here's RViz which is opened up, and I can see the image. Oops. Coming. We can go on to that perspective as well. So I can also, if you are wanting to do something like this, we can also move the robot around right now while we are also publishing the information for the image over. So let me source. So I am moving the robot over right now, and you can see at correspondingly the bottom left side of RViz that that same information is also being updated right there. So this was just a basic overview of how you can set up action graphs for ROS for subscribing to messages and also publishing messages, and a quick overview of how you can add a sensor to your scene, which in our case was the camera sensor. You can also do the same for a LiDAR as well, the physics LiDAR or the RTX LiDAR, and you'll be able to visualize the same laser scan information showing up on RViz like we did for the image message. So I'll quickly take a pause right now and we can answer a few of the questions which have come up on the chat. Ayush?
Yeah, so first thing, I think Adlan posted the error messages that he's seeing. So just looking at it, it seems like the robot either doesn't have an articulation root set up, or it's there's something wrong with the articulation tree, or perhaps the path might not be correct. So I would suggest just making sure that you do have an articulation root set up somewhere in the articulation of this robot. Otherwise, please do post on the forums, and we'll get back to you. We have another question from, let's see. So another question from Arjun here, asking about color description in Arvis 2. Yeah, I'm actually not sure what you mean by color description. Do you mean like the point clouds that we're publishing? If that's the case, I believe it's just it's either depth or it's yeah, I believe it's the depth information. So just depending on how far away a point is, it's just going to be colored differently in Arvis. But that's just something pretty arbitrary. You can set it up to whatever you need it as. And we have another question from Hattie asking about, how many turtle bots with their own graphs you can currently import into your scene. So this is, I think, dependent on the performance of your computer and your GPU, obviously. So yeah, just you can probably, we haven't really seen like a huge limit. Like we can't place a hard limit on this. I think it's just dependent on the hardware that you have. Another question from Godwill, asking whether there's an example of robot learning with ROS. So there, we don't currently have an example for that, but it is definitely doable, and something that I would suggest you to look into if you're interested in that. And otherwise, we'll look into creating a tutorial for this as well in the future.
We also did get a question from, I think, Karthik, who was asking that can we look at source code for ROS OmniGraph nodes? So the ones which are written in Python, yes, you can take a look at that. Let me quickly find one of them to show you what it looks like. The ones which are in C++ level nodes, unfortunately, no, you'll be only able to access them through the lib files which are generated after ISAXM gets compiled. So for the Python OmniGraph nodes, which you will write yourself, and Python level code, you should be able to use it directly and access the source code as well. But the other ROS nodes for ISAXM are written in C++, so there's no straightforward way to look at that. Uh, any other questions, Ayush, which we should be looking at?
Yeah, I see another one from Sanket asking about the action graph for Mecanum wheel robots. Again, it is so you'd probably likely need to use the I believe there's a Omnigraph node which is the let me try to remember, but there is definitely one that you can use for holonomic robots, like a controller that you can use for holonomic robots. Otherwise, you should be able to just apply the articulation view API on Mecanum wheels, and hopefully that should work. Otherwise, again, if you run into issues, please do post on the forums, and we'll get back to you. And I think last but not least, we have another question from Adlan asking about whether it's 2D LiDAR. So I think the example that Rishabh just showed is 2D LiDAR, but you can have 3D LiDARs if you use, even PhysX LiDARs have the capability of 3D, or RTX LiDARs just publish a point cloud. So that is 3D by default anyways. Yeah, I think that's all the questions we have. We have a suggestion from Samuel, and we'll definitely look into it. So thanks for the suggestion as to creating that tutorial.
Yep. And also I see a question from Hadi. Did we get this one? I can see a color image on RViz but not able to see depth image when echoing. I'm getting some data. Can it be QoS issue? Did we answer this one or did we miss it?
Oh, I might have missed that one.
Okay, okay, I can take that. Yeah. So,
Yeah.
Hadi, one thing to keep in mind when you're using depth images in particular is issues which we've seen is sometimes you've got scenes which have holes in them, and what I mean by that is there is infinite depth over there. So, what does happen in that case is you might want to echo your depth image topic and see what the maximum value is looking like. And if that does seem to be crazy off, then that probably is your answer that why it's not showing up in RViz because the depth images, once they're displayed, they're normalized and displayed. And if the number which they're normalized against is tending towards infinity, images might be washed out. So that might be one thing. But the other thing might also be that make sure that the environment is set up correctly so that you're not getting any weird depth values coming out from there. And any other things, I think the other thing which you could also look at is the encoding, which is a part of the depth images. And I'm not sure if that might be an RV specific problem, but if you could just generally check by subscribing to that particular depth image and seeing if the values look correctly in terms of the raw numbers itself, that might be a good starting point before visualizing it. Uh, yeah, I think those are the things which you can try out. And if you still do see the issue persist, then you can reach out to us on the forums by having the sample USD scene and the camera prim, for example, where it is in the scene, and we can take a look at it.
Yep, those are some good points, Rishabh. Thanks. And finally, just one last question that just came in from Ricardo, and just asking the difference between classic lidar, or I guess in this case we call it the PhysX lidar and the RTX lidar. The main difference is that PhysX lidar is using using PhysX directly, so it's kind of CPU based, and the RTX lidar is like the next generation, so you can actually define more things for the RTX slider. So it's similar to like an Hesai or a Velodyne. So it's kind of it's more customizable, and it also uses your GPU to process it. So it's just more powerful. And it's more efficient as well than the PhysX slider. So we do definitely recommend you to use an RTX slider if you're running into performance issues.
And another cool thing about RTX slider as well, Ayush, is on that topic is the RTX slider will also interestingly allow you to build robots in simulation which can navigate around people. What happens in case of the physics lidar is because there's no collision semantics set for the people objects in simulation, they're not picked up, but the RTX lidar is going to pick those up in simulation. And we're going to be looking at an example right now in a couple of minutes where we have the sample navigation scene opened up in Isaac Sim, and we'll be adding a person asset into it, and we'll see that the robot can dynamically look at that person asset and avoid it. And that happens only because the newer Carter assets and the navigation scenes have been updated to use the RTX lidar, and that lidar can pick up the people detections, which are useful in case you're having robots in scenes where the people are around. So that's super cool and interesting, and we'll be looking at that too. I think we can also now look at the custom Python message side of things. So let me quickly uh, turn off RViz for now and bring up the Python custom message tutorial. So the Python custom message tutorial is straightforward in the sense that first, we'll be using the Isaac Sim ROS workspace repository, which is also public right here. So in our humble workspace over here, we do have a custom message package. And this custom message package contains a sample message, which just has a string and an int. So our custom sample message contains of a string and an int. And what we want to do, right, it can be anything, obviously. It's something which, as long as you can define it as a message type under ROS and you can build that workspace, you should be able to use it with Isaac Sim. So at the Python level, it is going to be straightforward. So if you look at the tutorial right here, just need to clone the Isaac Sim ROS workspace, and we're going to build it, and we just need to source it. And once you've sourced it, you can import it into Isaac Sim, so it is straightforward. So let me get back to our Isaac Sim installation right here. Let me first uh, shut this down. Okay. And so I already do have the Isaac Sim ROS workspaces cloned over here. Let me go into the Humble workspace. I'll build it again. Okay, that's not good. Yeah, sorry about that. I think I'd built the workspace previously in Docker, so it is complaining that I need to have administrator level privileges. Okay, let me go ahead and build it again. There's a typo right there. Okay, so we do have a couple of warnings which have popped up, but I think we were able to build all our packages successfully. Uh, the standard error is related to the warnings for suppressing certain parts of it, but I think we're good. Okay, so let me go ahead and source, and let me see if the corresponding packages are showing up right here. So the name of our package was custom message. Okay, so yeah, I can see that the custom message package did get built successfully. So I've sourced the workspace now containing my custom message package. What I can do is let me go ahead and start Isaac Sim. So I've sourced the workspace which contains my custom Python message, and now I'm going to start up Isaac Sim. I'll open up the script editor quickly, which will allow me to run a sample Python script, and I'll try importing my custom message and seeing if it gets imported successfully. So that will be a quick check to see if things are working as expected. And it doesn't need to be the script editor. You can use it in a standalone workflow as well, as long as you enable the bridge before you source your uh, workspace, which contains your custom messages and packages. They'll be accessible through Isaac Sim. So that's mentioned right here. So you can use the script editor to actually access the custom message package which you had, or you can also have a standalone script where I just enable the bridge, and after I've enabled the ROS to bridge, I can make the ROS to related imports for RCLPy. And because I sourced my workspace as well, I can also import the custom message, which was a part of the newer workspace. We'll quickly take a look at the script editor over here. Uh, Make it a bit bigger right here. So this is importing RCLPy, and a quick way to actually check if your imports are happening from the correct place, as in terms of the packages location on your PC, what you can do is the following. So I'm going to import the custom message, and I'm just going to print its location. And over here, yeah, you can also create the sample message and assign some data to it. Let me go ahead and run this. Okay, so it did seem to run. So here you can see right here that the module custom message was imported from the isaacsim ROS workspace's humble installation from the right place. So this is where we'd actually sourced our additional workspace from. So this is how it's very straightforward now to import your own custom messages at the Python level with isaacsim, and especially on humble. However, if you're planning to use Foxy, uh, there is a way around, and let me quickly walk through what that would look like. So Ubuntu 22 with Humble and Python 3.10 is straightforward and super easy. For Foxy, what you would have to do is going to be that we do provide a Docker file in the isaacsim ROS2 workspaces, and what this Docker file, oops, not this one, sorry, right here. What this Docker file does for you is it's going to build the ROS2 dependencies for the isaacsim bridge with Python 3.10 so that you can use RCLPy as well with Ubuntu 20 and Foxy. So towards the end right here in our Docker file, what we're doing is we're building a workspace with the custom message package, and all of this is using Python 3.10. So this is how you can actually build your custom messages and packages into this. You can add it into the Docker file towards the end right here. And once you do that, you can mount that corresponding particular folder so that that can be sourced and used by isaacsim. So for doing all of that, you can follow through on the documentation right here. We've uh, highlighted it step by step in terms of what you need to do is building the Docker file, which is based off Ubuntu 20 and Foxy with Python 3.10, add your custom workspace in it, build that, source it, and then start sim. And that is how you should be able to run it directly. But I would recommend, if it is possible, working with Humble because it would make life simpler. And so this is it for the Python side of things. It should be straightforward to use custom messages with Python with the newer release of isaacsim, which now allows you to source your workspaces so that all of that can be loaded with isaacsim. And before jumping into the last part where we're going to be looking at custom C++ level OmniGraph nodes, Ayush, are there any other questions which you want to look at from the chat?
So there was a question about whether there's a standalone workflow for ROS2, and I think as Rishabh just showed here, there is, and we also have a tutorial on it. So yeah, it's called the ROS2 Bridge and Standalone Workflow. So that's definitely there. So please take a look at that. And we also have a question from Twitch that's asking, can you use a mining board and multiple 3090s with NVLink and use it with Omniverse? And I believe the answer to that is yes. We have multiple GPU workflows that you can use with NVLink. So as long as NVLink is active, I think that shouldn't be an issue. You may have to, I'm sure you may have to set up your drivers differently in order for that to work, but I'm sure there's documentation for that to set that up. And yeah, I think that's it for now.
Okay, sounds good. I think the last topic which I was looking at before we also take a quick look at nav if time permits is going to be a custom C++ level OmniGraph nodes with ROS2. So the workflow for this is a little more complex and probably more tailored towards advanced users of isaacsim or people who are looking to use or write their own C++ level ROS2 nodes with isaacsim because most of most of the stuff which is already there is all C++ based, and for camera helper and lidar helper nodes you can have the Python interface to actually interact with those nodes. But if you're looking to do custom workflows, this might be something which you would be interested in. So let me close this for now and let's head back to the tutorial right here. So the best way obviously to move forward would be to follow the tutorial as is, but I'll quickly give a brief overview of what the tutorial talks about. So it's going to the first step is going to be writing your own extension and getting it to compile with a base kit application which is provided right here. So this is the starting point for the repository, which is the kit extension template, which allows you to actually write your own extensions in C++ and compile it with Kit, and then that is how you can actually use it with Isaac Sim as well. So once you do write your own extension at the C++ level and you've compiled it with this version of Kit, you can import it into Isaac Sim, and that is how you can have your own custom C++ level OmniGraph nodes running with Isaac Sim. So let me open up the repository. I have a local copy of that right here. So Git extension template CPP, and we have the Ubuntu 22 version of it. S- So we do provide two zip files for this particular tutorial, one for Humble and one for Foxy. And that's because the headers for Foxy and Humble from the ROS side are structured a little differently. And that is why the corresponding premix file, which is used for compiling that particular extension, is different for Humble and Foxy. So let's quickly take a look at what I mean by that. So let's get into source and extensions. And this is our custom ROS to C++ OmniGraph node right here. And if you go into plugins, let's first look at the premix right here. So the premix is responsible for making sure that all the dependencies related to that particular extension are found. And in our case, if we look at the documentation right here, there are two things which we need to add on. One is your system level ROS, so that the system level ROS libraries which are needed for compiling this particular extension are found correctly. And the other one is the newer ROS workspace which you've added on top of it. So we've defined a custom message right here, which we're going to be using at the C++ level with an OmniGraph node. And we want to make sure that we are able to write a C++ level OmniGraph node which can access both these libraries, the system level ROS and the one which is generated from the newer message which you've written. So your system level ROS is already defined right here in terms of we'll be using standard messages, we'll be using geometry messages, the RCL level layer of ROS APIs. And you can take a look at this in terms of the dependencies right here. And this is the part which is interesting is the newer workspace which contains your message, the tutorial interfaces which we defined right here. And so the include and lib directories for actually building and linking towards the end is defined in the premix. And let's quickly look at the source code as well. Let me actually open it up. Right. So once you do compile the code, there is a file which is called database custom message node database which will be generated, and that is something which is common for most of the OmniGraph nodes which you will be compiling. And we'll be using the custom message from our tutorial interfaces which we just built earlier. So there's a compute function which is executed every time the node is activated, or basically when it is connected to playback tick. And that is when, if we do not have a publisher created, we are going to create that publisher, we are going to initialize it, and initialize it right here. And that's created. And towards once you have actually created it, you set the values for that particular message in the publisher and you publish it. So that's a simple overview of how things look like. The only new things which would be added here in terms of a regular ROS nodes uh, is going to be that first the OmniGraph. framework where you are accessing the compute uh, static function right here. And the second thing being that you would need to access it through the C level API, not the C++ level API. And that makes code a little bit longer, but we've given out examples of nodes in terms of how that can be done. So once you've written the code for this, and all of this is part of the tutorial. So I know this is probably a lot of information to digest right now, but excuse me, walking through the tutorial would really be helpful. And if you do run into problems, please reach out on the forum. So you will need to download the extension right here for Humble or Foxy, depending what you need. Make sure that you set up the right paths and you build the extension right here. So what we can do is you just need to hit build, and once you've cloned the repository, you've also set the paths correctly. After you've built it, you should be able to now use it directly. So what I mean by that is, okay, and just a second, let me look for that command. Okay, so this is going to start up the minimal kit which we have right here, which is going to include our custom built extension. So once we can see that it works as expected over here, so this is the extension which we just created and looked at. So I'm going to enable it right here, and it is complaining. Okay, yeah, that was my bad. I did not source my ROS installation before trying to enable the bridge. So that is why it complained. Let me go ahead and run it again. The error which popped out over there is probably because it was trying to load some libraries dynamically, but it could not find. Hopefully, we don't get that error again. Okay, we do. Oh, I did not source the tutorial interfaces library. Okay, the newer one which we just created. So the Humble workspace should contain our tutorial workspaces. Yep, this is right here. So let me just source this one too. So just make sure that both your ROS installation as well as the newer workspace which you are going to use the message from installation is also sourced, because libraries from both those places are going to be pulled in at runtime to make sure that you can access the publishers and subscribers and all the related functionality over there. I would hope it works now. Okay, so yeah, the startup was successful and you can go ahead and you'll be able to create. Yeah, you should be able. I'll have to enable the action graph related extensions as well. Let me enable the action graph related editor. Okay, what this will allow me to do is create action graphs. And right here we can see our newer nodes which we had created, custom message and publish string. Custom message right here. So this is the message which we just looked at, which we had created, where the sphere messages are custom message, and we are setting values for the center and we are setting values for the radius, and that can be done. right here. And keep it to the default value and hit play. So we did not see any error showing up. That was good. Let me go ahead and see on the ROS side of things if we can. So I can see that the custom node is showing up right here. So this is how you can check that. So this is how you can basically write a C++ level OmniGraph node and get it to compile, excuse me, with a minimal kit version. And on the next steps for the tutorial, you'll see that you can get it into IsaacSim as well. And adding the extension to IsaacSim. This is something which we did not cover right now, but that is straightforward. Once you've built the extension and tested if it works fine there, you can get it into IsaacSim. So we've been able to see how you can set up robots in simulation once you've gotten them in from the URDF importer, how you can set up sensors and make sure that uh, ROS is working as expected, even if you do not have it installed, and how you can use the bridge. Also looked at custom C++ and Python messages with ROS. I think towards the end, I wanted to cover a little bit of the navigation, but we'll quickly hop over to the questions if we have any more.
Yeah, so I see another question from Hattie asking, if we have multiple nodes in the same extension when trying to use the node description editor and adding some inputs and outputs, the database scripts might be getting deleted. So what would be best practice? I'm not sure why you are facing this issue. I have tried it. So I believe what you're referring to here is the Omnigraph script node. Or no, sorry, creating your own custom Omnigraph node using the editor. Now that I believe, I mean, if you just click on save node, that should be persistent. So there shouldn't be a case where it's being deleted. Um, yeah, maybe if you can ask that on the forums, we will get back to you on that.
Okay, thank you, Ayush. I think, yeah, towards the end, I'm just going to quickly look at the navigation sample which we had, and I think we can then wrap it up.
Yeah, it sounds good.
Let me share my screen again. Okay, so let's quickly look at the navigation sample right here, which is a part of the tutorials as well again. Uh, Basically, following through this tutorial and running navigation is something which you can take a look at. The only thing which we'll be adding here is we'll be taking a look at the people as. So this is the sample navigation scene which comes as a part of Isaacson. Uh, what I'm going to do right now is I'm going to don't want to publish information, image information over to ROS, so I'm going to disable the render product for doing that. And let me go ahead and add a person to the scene. So this is the sample person which I'm adding into the scene right now. And once I will hit play, let me also on the other side uh, get my Isaac Sim ROS workspaces uh, up and running. So okay, so that is good. Let me hit play here. And on the other side, Let me find the command for actually running the nav from the ROS side. Okay, so simulation is started right here. Let me go ahead and run the navigation for the Carter. So this is nav showing up right here, and if you will look closely, you can see already that it is picking up something. Let me go ahead and move the Carter. So you can see that it's picked up a dynamic obstacle, which was the person in our case right now. So it was not a part of the map initially, but this is something which you can now do with the RTX LiDAR and a robot of your choice if you've got nav set up on it, that you can have it in the scene and it is going to pick up the people in the scene through detections from either the 3D or the 2D RTX LiDAR, which were not initially picked up by the physics LiDAR. So this is something which is a part of the newer release, and you can also set animations for people to actually walk from one place to another and do certain tasks. For doing things like that, you can look at the Omni Anim People extension, which is part of the Isaac Sim docs as well. We look for it right here. Is it scene setup? Mhm. I think it's, yep, right here. So this is the omni.anim.people extension, and it has animations for actions like looking around, standing in a queue, or walking to a certain destination in the scene. So you can also add robots into the scene, which will now be able to pick up people doing these actions dynamically on the fly with the RTX LiDAR. So if that's something you're interested, I would suggest looking at the Anim People extension, and the navigation, excuse me, scene already does exist with the Carter setup, so that you can have people in the scene which will be detected while uh, you're moving the robot around. So I think that was the last thing I wanted to run through today. Let me stop sharing my screen and we can take a look at the questions towards the end. Do we have any other questions? Are you sure? Are we good?
Can we save? So another question just came in. How can we save an omnigraph that we have created? So I believe if you look into the documentation for creating an omnigraph node, uh, that should that should walk you through how to save certain things. Um, let's see. So in the properties, you have like save node, you have generate blank implementation, edit omnigraph, edit node, all these buttons. So I believe just if you go ahead and create a blank implementation first, then you edit the node, do whatever you need to do inside there, and then if you just hit save, that should be it. And it's saved under your kit folder. So that's where it is if you're looking for it. And another question from Abdul asking about we facing some difficulties with the Python environment installation in Linux. Um, yeah, if you could send the error, that would be great. Again, you can also post it on the forums, and we'll definitely get back to you for that.
I think Adlan also has a question on how do I connect UR10 with Omniverse. Not sure I understand that question entirely. We do have the UR10 robot if you're looking to simulate it with Isaac Sim, and if you're looking to do actually something like software in the loop or hardware in the loop, where you've got the robot running in Sim and you also have it running in the real world, then if you can make use of the ROS2 bridge which we have, and I think that should provide you with all the functionality you need to have the simulated robot run with the real robot as well. So I hope that answers your question. But I think in general, if you're running into problems and it would be really helpful if you post them on forums so that we can help answer those questions. And I think thank you so much for joining us today. If that's all, we can stop the live stream.
Yeah, just one last question. Is there any
Sure.
drone support coming in the foreseeable future? I think at the moment we are looking into this. And yeah, we'll definitely let you know once we have anything about the drones in Isaac Sim. But yeah, we're just looking into it currently. And oh, Adeline just posted another thing about UR10 in the real world. Perfect. Yeah, so I think Rishabh kind of answered his question already, but essentially you can use multiple ways to connect to the UR10, but one way would be to use ROS as well. So yeah, I think that's it for now.
Thank you so much. Thanks, Ayush.
Thanks for having me, and
Yep.
yeah, and so excited to see everybody on this chat.
Yep. Had a lot of questions. I think it was a good session. So thanks, everyone.
Thanks, guys. Bye.